Hi, today we're going to do a review for adding fractions with different denominators. Note this is a review and not designed for beginners. To be successful, you need to have a general idea of how to add fractions with common denominators, and you need to be able to find a least common multiple. Now, while I expect you to be able to add fractions with common denominators, we are going to take a quick look at an example just to review what we're doing. Here we got 1/5 plus 3/5. Notice the first circle is broken into 5 equal sections, one of them shaded in. The second circle is broken into 5 equal sections with 3 of them shaded in. So since they have the same denominator and equal sizes and shapes, we can add the 2 of them together. And we notice that we create a circle of 5 equal sections, and 4 of them are shaded in. So our answer was 4/5. We were able to get that algebraically by keeping the denominator the same and then adding the numerators. The 1 plus 3 gave us the 4. So algebraically and pictorially we come up with the same answer. Now, when we start doing ones that have different denominators, here we have 1/2 plus 1/4. This one's not too bad because we can take the 1/2, we can take the 1/4, we put them together. We see that we make one circle with 4 equal sections. 3 of them are now shaded in, so our answer should be 3/4. The question becomes, how do we get 3/4 from our 1/2 plus 1/4? I'm going to recommend doing this algebraically with a few steps. First of all, we're going to want to find the least common multiple of the denominators. So let's look at our denominators. We have 2, we have 4, so the least common multiple of the 2 and 4 should be 4. Next, we're going to multiply each fraction by the appropriate representation of 1. Now, I know this sounds really weird, but if you think about the multiplicative identity, which is 1, you can multiply anything by 1 and get your original equation back. Now we're starting with 1/2 plus 1/4. So if we're going to multiply by 1, 1/2 times 1 is still a half. 1/4 times 1 is still a fourth, so we have not really changed the problem. So what I mean by an appropriate representation of 1 is we're going to make some equivalent fractions to replace the 1. Now to do this, we're going to take our least common multiple, in this case the 4, and we're going to divide by the denominator in each case. So for the first fraction, the 1/2, we're going to take the 4, and we're going to divide by the 2. 4 divided by 2 is 2, so we're going to make an equal representation of 1 in 2/2. For the second fraction, once again, we still got the least common multiple of 4. The denominator in this case is 4, and 4 divided by 4 is 1, so technically we would multiply by 1/1. If we do the math, on the left side we have 1 times 2, which is 2. 2 times 2 is 4. On the right side of our equation, we got 1 times 1 is 1. 4 times 1 is 4. All right, at this point we now have equal denominators. So under normal circumstances, we now add our numerators. So the 2 plus 1 gives us 3. So algebraically, we would come up with 3/4. Notice that matches what we got when we did the picture. Let's try another example. Here we got 3/4 plus 1/6. So the circle on the left is broken into 4 equal sections. Circle on the right is broken into 6 sections. If we take and put these together, notice, if you look carefully, these are not broken into equal parts when we look at it. So we're going to have to find a common denominator. So we'll start with our least common multiple. So our denominators are 4 and 6. The least common multiple of 4 and 6 is going to be 12. So remember, we're going to be able to multiply by 1. So if we check it out, the least common multiple is 12. 12 divided by the 4 is 3. So if we do 3/3, we have an equivalent expression for 1. We take the least common multiple of 12, divide by the 6, we're going to get 2, so we're going to place that one with 2/2. So if we do the math, 3 times 3 is going to give us 9, 4 times 3 is going to give us 12. On the right pair of fractions, we got 1 times 2 is 2, 6 times 2 is 12. We now have two fractions with common denominators, so we can do what we normally do, which is keep the denominator the same and add the numerators. The 9 and the 2 should give us 11. If we check this out pictorially, circle on the left is now broken up into 12 equal sections. 9 of them are shaded in. Notice that matches up pictorially with the 3/4. The circle on the right is broken into 12 equal sections with 2 of them shaded in. That matches up with the 1/6. So now when we put them together, once again we got the same amount of the circle shaded in as we did before, but now we got 12 equal sections. And 11 of them are shaded in, so it matches up algebraically and pictorially. Let's try another example. Here we got 2/5 and 1 plus 1/2. So the left circle has 5 equal sections, 2 of them shaded in. The right circle has 2 sections, 1 shaded in. When we put them together, in this case, we definitely see that we do not break it up into equal sections. So to find a common denominator, we'll start with our least common multiple. Here we're dealing with the 5 and the 2. Least common multiple in this case will be 10. Now remember, we're allowed to multiply by 1. So we want our appropriate representation. So least common multiple is 10. If we divide by 5, we're going to get 2. So we're going to replace the 1 with 2 over 2. In the 1/2, we take the 10, we're going to divide by the 2 in the denominator, we're going to get 5. So we're going to multiply by 5 over 5, an equivalent representation of 1. If we do the math, 2 times 2 is 4, 5 times 2 is 10. On the right pair of fractions, 1 times 5 is 5, 2 times 5 is 10. Note we now have our common denominator at 10. So we can add the 4 and the 5 and get 9. From a pictorial representation, circle on the left has 10 equal sections, 4 of them shaded in. Notice that matches up with the 2/5. Circle on the right has 10 equal sections, 5 of them shaded in. Notice that matches up with the 1/2. Now when we put them together, we get one shape with 10 equal sections, and 9 of them are shaded in, matching up algebraically and pictorially again. For our last example, we have 1/3 plus 3/4. Notice if we take a look at this one, we end up with not only a whole thing filled in, but there is probably some overlap. A little hard to tell from the picture, but we know we got at least one whole unit there, and there's probably a little bit extra overlapping there. To check that out, let's do our least common multiple. 3 and 4 are denominators. The least common multiple in this case will be 12. Yep. So we're allowed to multiply by 1. All right, so with the 1/3, if we take 12 and divide by 3, we're going to get 4. So we're going to do 4 over 4, an equivalent expression for 1. For the 3/4, we'll start with the 12, divide by the 4 in this case. So we're going to replace the 1 with 3 over 3. If we do our math, 1 times 4 is 4, 3 times 4 is 12. On the right pair of fractions, 3 times 3 is 9, 4 times 3 is 12. Got the common denominator of 12, so we can add our numerators. 4 plus 9 is 13. All right, if you remember from the common denominator video, if the numerator is bigger than the denominator, we got more than one whole unit there. So let's take a look. Left circle here has 12 sections, 4 of them shaded in. Sure enough, that matches up with our 1/3. Circle on the right, broken up 12 sections, 9 of them shaded in, matches up with our 3/4. If we put it together, we're going to have more than we need, so we're going to have to break one of them up. So let's break up this one on the right. All right, so if we take 8 of those 12 sections and filled in with the 4 sections we got, we end up with the whole unit, and we got a little bit left over. So we're going to have 1 whole unit, and then we got 1/12 left. Hope this has helped you with any problems you may have been having adding fractions with different denominators. Have a good day and good luck, everyone.